mutual inductance. We will discuss the entire discussion in absence of ferromagnetic materials. Now, if you see to the picture, the mutual inductance is such that it is the property of two coils by virtue of which each coil opposes any change in the flow of current in other by developing an induced EMF. Here, if you see to the picture, during switch on, the primary current from the battery flows in primary coil, causing a sudden deflection in galvanometer in the secondary coil. And this sudden deflection of galvanometer in secondary coil confirms that there is a current, that is secondary current, in the secondary coil. And again, when switched off, also the deflection on galvanometer is observed, but the deflection is exactly opposite. These deflection observed only during switch on and switch off. So, if you see, the direction of secondary current is such that it opposes the primary current, and in fact it opposes the changes in flux, and the opposition depends upon the geometry or the system how you have selected the components. If you pick up the primary currents, secondary currents as IP and IS respectively, ES and EP are the induced EMF in secondary and primary. Phi S is the flux in secondary coil due to flow of current in primary. Phi P is the flux in primary due to flow of current in secondary. The magnetic flux associated with secondary is obviously directly proportional to the current in primary. More the current in primary, more is the magnetic flux that is associated with the secondary coils. So therefore we can write that the phi S is directly proportional to IP, and which will give us that phi S is equal to some proportionality constant, let us say MSP times IP, where MSP is the coefficient of mutual inductions of secondary with respect to primary. And obviously from Faraday's we know that the rate of change of magnetic flux gives rise to EMF. So here, if phi S is equal to MSP times IP, so minus d phi S by dt must be equal to ES, that is secondary coil EMF developed, and that must be equal to, if you substitute the phi S value, then it will give us MSP being constant taken outside, so minus MSP times dIP by dt, which will be equal to the EMF in the secondary coil. In the same way, you can write that the magnetic flux associated with the primary is directly proportional to I secondary, and which will give you phi primary must be equal to MPS times I secondary. And again from Faraday's, the EMF induced in primary must be equal to minus d phi p by dt, which must be equal to minus MPS times dis by dt, where MPS is again the coefficient of mutual inductions of primary with respect to the secondary. From reciprocity theorem, which will be discussed in our subsequent class, that MSP must be equal to MPS, which we can say as M, let us say. Characteristics, if you see to that of mutual inductions, are that mutual inductions due to two coil or a system is the same irrespective of current flow in any of the coil or any of the components. And mutual inductions and self-inductions are simultaneous process. And mutual inductions depends on geometrical factors like length, area and number of turns as before in case of your self-inductions. But in addition to that, mutual inductions depends upon the separations and orientations of the coils or the parts. Supposing you have taken two coils, then the orientations and the separation between the coils. Again, if you see to the formula, that is rate of change of current, primary current, if you set equal to 1, then you can see that the EMF developed in secondary coil is equal to, magnitude wise is equal to the mutual inductions. So therefore you can define that mutual induction due to two coil is equal to induced EMF set up in the first coil due to change in current rate at unity. And the negative sign is obviously by that of your Lenz's law, which ensures oppositions of the change. And unit and dimensions of the mutual inductions is as same that of your self-inductions we have discussed. Now coming to the applications of these mutual inductions, you can apply the concept to find the mutual inductions between two concentric ring or two concentric coils carrying current. Now if you see to the picture here, B1 which is equal to field at the center of coil C1 due to current I1 in the circuit, that must be equal to mu 0 times N1 I1 by 2 R1, and the total effective flux linked with C2, the coil C2, must be equal to phi 2, which is must be equal to N2 times B1 A2. It is because the N2 is the number of turns associated with the second coil and A2 is the area of the second coil. So therefore the magnetic field at the center of the coil C1 times the area, that is the flux, and that has to be again multiplied with the number of turns of the N2 number of turns in the coils. So therefore the phi 2 must be equal to N2 times mu 0 N1 I1 by 2 R1 times A2, where our A2 is the pi R2 square. Now if you compare this expression with the phi 2 which equal to M times I1, so you can get that the mutual inductance coefficient must be equal to M equal to mu 0 times N1 N2 times pi R2 square by 2 R1. And in the same way you can find the mutual inductance between two coaxial solenoid also. If you take S1 is the inner solenoid, in this case then B1, capital B1 must be equal to the field inside S1, that is equal to mu 0 times N1 I1 by L. So therefore the total effective flux linked with S2 must be equal to phi 2, which equal to N2 times B1 A2. So therefore that must be equal to N2 times mu 0 N1 I1 by L times A2. Again if you compare to the expression phi 2 equal to M I1, then the mutual coefficients M must be equal to mu 0 times N1 N2 upon L times A2. And if you carefully mark, the inner and outer radii in these two pictures are interchanged. It is to ensure that the mutual inductions does not depend which one is you are taking primary or which one you are taking secondary. But in case areas are different, then the inner solenoid are taken for calculations. And if the lengths are different also, then the longer solenoid length has to be set in the calculations for formula. We will discuss some more supplementary discussions in our subsequent class about this.